Hi all, welcome to Cyber Warfare Labs AWS Cloud Red Team course. In this module, we will discuss about container services provided by AWS. So you can see table of content. First, we'll discuss about the containers. What is the difference between traditional containers and the containers there in AWS? What are the components there in containers, just like Elastic Container Services, Elastic Kubernetes Services, or container registry? And in the next module, we will discuss about how we can exploit each and every services, how we can enumerate using command line utility, how we can get the initial access using compromise the container services. So let's start. So first we'll discuss about containers. So you can see basically in AWS, container services in AWS can be broken down into three categories. So basically in AWS we have three categories. It's overview of the containers. First one is registry. So basically registry give you the secure place to store and manage your container image. So suppose if you have your Docker image where you can place it. So you can use Docker Hub or any public repository or any private repository, but container AWS also provide a container registry where you can place your registry either a public as well as in private mode. So it's basically a storage to store your public or private Docker images. The service name of this storage is called Elastic Container Registry. Second thing, we have orchestrations. So basically orchestrations manage when and where your container run. So all the management done by two type of orchestration services in AWS. First one is Amazon Elastic Container Services and second one is Amazon Elastic Kubernetes Services. So these are the two services which is basically manage your containers in AWS. Third one is compute. Actually, compute engine is used for run your container. So where you want to run your containers. So AWS provide two type of compute where you can run your containers. First one is AWS Fargate. So Fargate basically is serverless compute engine which is completely managed by AWS. All the patching, everything will be managed by AWS. And second one is traditional Amazon EC2 instance. So this is just like a virtual machine where you can run your your containers. So these are the three things which basically comes in each when we're talking about container services. We'll discuss later on how we can enumerate all the information using command line utility and how we can misuse if your application is running on container services as well as Kubernetes services. And how you can take advantage of if your container is running on Fargate as well as EC2 compute instance. So it's basically depend upon the organization in infrastructures, how they set up all these things and how they uses the services of AWS. So you can see here in this diagram, let me explain. So this is your traditional on-prem container or Docker environment. This is the environment we have in AWS. So you can see this is basically traditional Docker environment. In your on-premises you have infrastructures. Basically you have your own VLANs and all everything. You have your operating systems where you have run Windows as well as Linux operating system. On top of Windows or Linux or top of operating system you install the Docker engines. So basically Docker engine is just like an application you can install on top of operating system, and then you can run whatever containers you want to run on this top of engine which is installed on operating system. So basically this is the architecture of traditional containers or traditional Docker environment we have. If you're talking about VPC or sorry, if you're talking about AWS environment, how it's look like a Docker environment. So first thing, just like you have infrastructure in your traditional or your on-prem environment, in AWS we have a VPC. VPC basically manages all the networking part. So you can have this containers or Docker environment in private VPC, public VPC, and how it's accessible. Second thing, you have the instead of host operating system, well, basically you have either EC2 as well as Farragut. It's a compute where your container is running. On top of this compute engine, you have a Docker engine, and same like we have a Docker, you have a Docker engine, you have all the containers like that. So these two things is different. This is your on-premises, like your infrastructure as well as operating system. Same like you have a VPC as well as your the compute engine like EC2 or Fargate. So these are the difference between your on-prem container environment as well as your AWS environment. Now we're talking about a registry where you are going to download the container image. So basically you have a Docker engine. How you can download the Docker image? So there is a three-way you can download the Docker image. Suppose if you are in your on-premises, you can download the Docker image from the Docker Hub, that is public repository, or you can download the Docker image from the private repository, because there is organizations, they have their own Docker repository. If you are there in AWS, you can download the Docker image from public repository, Docker Hub, your private repository, as well as AWS also provide a container registry services. So this is called AWS Container Registry Services, which basically take care of to store all your Docker images. So you can store in a public manners as well as private manners. You can also use these services in your on-premises to download any Docker images from this registry. So this is basically general difference between traditional Docker environment as well as when we have a Docker environment or containerized environment in AWS infrastructures. Now we discussed that there is a registry, we already discussed. What about the compute? There is two type of compute. Now when we're discussing about orchestrations, there is a two type of orchestration which is basically managed when and where your container runs. So it's basically management part, how you can manage your container services. So there are two type of services. One is Elastic Container Services and second one is Elastic Kubernetes Services. Let's discuss about each and every services one by one. So first we'll discuss about Elastic Container Services. So you can see here Amazon Elastic Container Services, that's called ECS, is a fully managed container orchestration service that provides the most secure, reliable and scalable way to run containerized application. So basically you can see here you have to create a cluster. In cluster you can define the number of nodes. When you're talking about nodes, you can use EC2 instance or you can use Farragut. You have to choose at least one thing. Either you can choose EC2 instance or you can choose the Farragut. All the images, all the Docker images will be there in pre-built. Either you can choose EC2 or Farragut. You have to define the task, you have to define the services, that's it. You no need to manage all these things. So all Docker engine will be there in by default for EC2 instance as well as Farragut. So you have to just run the container, you have to download the images from registry. So you can use Amazon Elastic Container Registry Services where all the images will be there. You have a repository, images will be there. You can download these. A repository on Docker engine which is running there in EC2 as well as Farragut, and you can run your container. You can run your services as well as tasks. So everything is managed by ECS. So here, when you have a multiple, you can create the services, you can create the task. When you require a, multiple containers, it will automatically, scale the containers, and it will also help you to, reduce the single point of failures. So this is, the container services or orchestrations provided by AWS itself. There is a second orchestration. Okay, let's first discuss about how Elastic Container Services look like in practically manners. So you can see here, we discussed this one. I already logged into my AWS Management Console. Let's type here container. Container services. So you can see this is the Elastic Container Services. First you have to create the clusters. So basically Amazon ECS cluster is a regional group of one or more container instance on which you can run the task. So basically if you have a multiple nodes either EC2 instance or Fargates, you can create a clusters where you can run the task. So you can reduce the single point of failure. If one node is not working, so it will automatically up the another node. If one container is not working, it will automatically up the another nodes. So this is the container or ECS look like. You can create the cluster. Suppose you can go here, you can create the cluster. So you can choose. There are three options. You can choose it. If you're going for a Fargate, you can choose the networking only. So you can set up the VPC, subnet, and all these things, but your underlying compute engine will be the Fargate. So you no need to manage the Fargate. Everything, patch management, everything is managed by AWS itself. Now, second thing, you can go for a EC2 instance. So you have to choose the instance. Here you have to choose the instance, operating system as well as networking part. You can choose your Windows as well as Linux. So this is for Windows, this is for Linux. So you can, basically you have to choose the networking part, VPC, subnets, and all these things, as well as the whatever operating system you want for this particular EC2 instance. But you will be responsible for patch management. You can, it's basically start a EC2 instance where a Docker will already be installed. You have to manage all these things. But if you're going for a Fargate, you don't need to manage, worried about compute or patch management. You can only look for the networking where you want to run all these clusters. So this is how you can configure the clusters. So suppose in this case, I have two clusters. One is Red Team ECK cluster and second one is ECK cluster 1. So I have a two cluster. In this cluster, you can see we have a Fargate. So you can choose Fargate as well as EC2, or you can choose the both. So I choose the Fargate. I have one services and two tasks which is running there. So you can see all the data here. If you can choose EC2, you can see the respective information here. Same like in this cluster, I created the cluster, but I don't have any service or any task. So this is how ECS is look like. So basically you can define the task, you can define the services here. So let's click in this cluster. So this is a cluster 1. This is the ARN of this cluster. You can see how many task is running there, task count, active count. So you can see this is the services. This is the task sections. EC2 instance, I don't have any EC2 instance because I'm using the Fargate. So you no need to do all these things, because if you have EC2 instance, you can manage it. So this is how you can schedule the task. You can do all the operations. So basically here you can define the services. Here you can define the task. You can create a new services. You can create a new task. Suppose I'm just creating the services. You have to specify that new services will be running on the same Fargate, or it's launch a different EC2 instance. You can define the task. This is how it's look like. You can also configure the basically task. You can create a new task. So currently you can see I have a two tasks. Let's click on the first task. So this is the task definition I have. So this is a VPC mode. I have roles, how we divide the task, and what are the required attributes tab. So this is how it's look like. You can also see there in this one. You can if you have this JSON file, you can choose this one. Port, the exposed port, all this thing you can see here. You also define the task. So this is how it's look like. You can do multiple things here. So this is overview of how ECS is look like, what you can do. You can create the services, you can create the task, and this is all about. So you can change the settings here. But this is basically an overview for a red team perspective, how ECS is look like. What are the information you can enumerate, or whatever thing you can look when you doing for a red team activities. So basically you can check that where is this services is running, what is the when you click here, you can see this is the task is running, which instance they use. Either they are using Fargate or they are using EC2 instance. Suppose if I click here, Let's click this one, task definition, everything. Let's go back. You can also update the task. You can create a new task. You can run this task. So let me show you one thing. So this is the services task. Okay, yeah, in this case you can see all the details about this particular task. So this is the cluster name, this is the task definitions, status, you can see it's running, networking part you can see here, the public IP address as well as private IP address. Let's go to this. So you can see AWS Red Team. So task is running there. Container, basically this is the container, they are running this particular task. So this is how look like, networking part and all these things. Even if you have a CLI access, or you have a secret or access key, you can enumerate all the information using CLI. But for the red team perspective, you should understand about what is information I'm going to enumerate. One is what type of services they use. Either they have a cluster, then in cluster what are the nodes they have a Faragates as well as they have EC2 instance, and if they have EC2 instance or Faragates, what is the services and what is the task, and you can describe the information about task as well as services. So this is how ECS is look like. Now let's go for a second services we have. Second, we have orchestration is Elastic Kubernetes services, which is really popular, and now these days a lot of organizations is using Kubernetes. So Kubernetes basically, when you're talking about EKS, is all managed by AWS. So it's basically fully managed Kubernetes services that provide the most secure, reliable, and scalable way to run containerized application using Kubernetes. So you can use the Kubernetes to run these applications. So when you're talking about Kubernetes, when we have a traditional way, we have a master node as well as worker node. Same like in EKS in AWS, we have a control plane where we have master node as well as worker node. We have a node similar. So you can see here in this diagram. Suppose when you create a cluster, it will be the total will be the cluster. You can see this is a cluster. In this cluster, the first part is this one is a master node. We can also say is a control plane, which is just like you have your master node. It's basically a master node which is also have a control. We can also say it's control plane. And second thing, we have this one, we have a worker node where your EC2 instance or Fargate will running there. So this will manage all the activities, just like when you want to upscale, when you want to run a new deployment, when you want to run a services, it will be API will be running here. It's basically API. Kubernetes API will be running here on the control plane. We can say master node, and these are the worker node which is listening for the API and do all the operation which is defined by this API. You can manage this API. You can create a deployment. You can create a services. You can check using kubectl. So you can use kubectl to connect to this API using this network load balancer. So it basically depends upon how the API is exposed. Is API is exposed to the public? Is API exposed to the private, or API exposed to both public as well as private? So you can use your kubectl command line utility to just like you use in traditional management of managing the Kubernetes services. So you can connect to this API endpoint and you can perform all the tasks here. Second thing, this is the worker node where your actual task and application is running. So there will be one load balancer which will be you can as a client or as a user, you can use the web client to access these applications. In the backend, all it will be take care by your control plane, how the how you can manage the worker node, how you can if there is a more loads is coming, how you can transfer it. And there is load balancer which is running here, which is also applicable for managing the load balancer on the application layer. So it's basically, for a red team perspective, why it's important, you should understand about the architecture. Because suppose you are a red teamer, to get the initial access using web client, you get the initial access on one of the nodes. How you can literally move within the how you can break the containerized environment to access this particular node. So initially you maybe have the access on the containers which is running there on this node using any remote code execution vulnerability or any other vulnerability. How you can break this environment to full access of this particular node. Then once you have access of this node, how you can move laterally to compromise other node, either EC2 instance or at forget profiles or forget nodes. If you compromise all the worker nodes or this VPC, because by default there should be one best practice that both the node, master node, this is the master node and this is just worker node, should be have in the different VPC. So how you can compromise all these environments? Suppose if you compromise this worker node environment, how you perform the lateral movement to access this API or to compromise this your master node as well as control plane. If you compromise this control plane, that means you can have the full access on your cluster. So you can perform whatever operation you want to perform. Third thing is container registry. Basically, just like we have a use a container registry in our ECS services. Same like if you have the image, you can use the AWS Container Registry to either download or use the image in your worker node, or use the image for your running application. So basically this is a really important, because from a registry perspective, when you perform a persistence, you can create the backdoor in the image. You can download the image, you can upload the image with adding some backdoor. So whenever application or container use this image, your backdoor will be executed at that time. So maybe you will get the reverse shell, or you can do any other operations. So this is how the architecture you should be understand about how it look like. So there is another thing is, so suppose if your VPC and customer VPC, ECK VPC and customer VPC. ECK VPC basically for control plane, customer VPC for your worker node. If they are in different VPC, you should check how communication is happen, how worker node is communicating to this API endpoint. Because to getting the instruction and to sending the result, it should be communicating to this API endpoints. You can see kubectl should also communicate to API. So how the communication is happen? Is it a private communication? It's a public communication, or it's a both? So it's really a matter, because in this kind of situation you also have this ENI. That means you can communicate from here. You no need to have the VPC peering or any other thing, because there is a ENI which is already attached to both the VPC. So you no need to have the VPC peering to communicate from one VPC to another VPC. And this is really important, because ENI is directly attached. It's basically elastic network interface, which is attached to both control plane as well as worker node. So suppose if you want to access the control plane from this worker node, you can directly access it using this ENI and the configuration they have in their environment. It basically depend upon organization to organizations. But it's really important, because this thing will help you to perform your red team operations like lateral movement or pivotings and all these things. Let's see how it's look like practically. Suppose I EKS type the elastic Kubernetes services. Let's see how it's look like. It's similar to ECS. You have this thing. So suppose you have to create a cluster, same like we did in ECS. You have to create the cluster. Suppose this is the cluster I created. This is a version you have. You can create a new cluster. Same like you can define the node. So all these things are the worker node. So you see here, these are the worker nodes where your application or your container actually is running there. So this is the worker node profile. So currently I have 2 worker nodes. You have a multiple worker nodes here. And then these are the we can say namespace there in this particular Kubernetes environment. and there is a configuration. So this is the API endpoint. So you can see here, this is the API endpoint. You can access this endpoint. So it's basically relate if you can access this endpoint from the public, or it's only restricted, or it's only accessible from within a VPC. So when you configure the cluster, you have to define it. These are the information you, are for your master node, or we can say your control plane. You can also use the OpenID connector URL to connect to this API. This is the certified authority, the certificate we have. Cluster ARN as well as role, which is attached to this cluster. So this cluster can, have a rights to run any other, EC2 instance or forget profiles. You can also set the encryption strings. Let's go for a compute. So basically you can see I have a node group you can create a multiple node group. In node group you can define the number of EC2 instance or forget you have. So node group is basically for EC2 instance. You can create a forget profile as well. So number of forget you want to use it. You have a networking. So this is the VPC information, this is the subnet information, and you can see API server endpoint accessible. When we see the API, this is the API and which is accessible from the public. You can also restrict here using security groups, or you can also restrict using the CIDR block. So suppose these are the IP address can access the API, but while doing your red team operation, if you found that you can access the API from the public, it's really very critical for an organization, because you need a few details or authentication token to directly authenticate, and then you can access all the operations. Then add-on logging facility, you can also enable the logging facility here. So this is how a cluster is look like for EKS. But the main motive is to understand about how the architecture is look like, where you have your worker node, in which VPC they belongs, which VPC your control plane belongs to, how we can communicate, what is ENI, how we can access the APIs, endpoints, and how we can access the applications. You can see here in this, when go for a networking, let's go for, I think when you go for a details, these are the information I get it from there. Let's click on the node group. Yeah, node group. Yeah. So it's basically contain all the information. So see, when you see here the networking, this is information for your control plane as well as master node. But when you click the node group here in compute, when you click on the node group, these are the subnet and VPC which is belongs to your worker node. So this is a really important. There may be situation they both should be there in the same VPC, but most of the organization they have a separate VPC for best practices. So maximum number of node, minimum number of node, desired capacity when it's required, ARN which is attached to node. So this is also important, because there may be case that you compromise the node which have your higher rights, or which you attach the higher IAM roles. Then these are the subnets which is these nodes belongs to or can run their nodes in these subnets. So allow remote access to these nodes, so it's enabled. So if you compromise the key, you can directly access these nodes. So if you access these nodes, you can access the containers and you can access the other thing. So this is how it's look like. For all information, this is how it's look like. Auto scaling group. Yeah. So so basically, this is how it's look like for. Let's see for this networking part. Details we already discussed. Yes. So this is all about how you can identify, how you can know about networking or network diagram of clusters. So a lot of organizations have a different approach. They have a separate VPC for control plane, worker node as well, and how you can communicate it. And at the end, how you can download the registry. So we'll discuss about registry services. So how you can store your images. So I think this is all about EKS. Let's move to the third one, is container registry. So basically, Amazon Elastic Container Registry is fully managed container registry that make it simpler and faster for developer to store, manage, and deploy container images. So basically, this is really important, because what is happening, most of the organization, they can develop their own container on Docker images, and they can use ECR to host their registry. Why it's really important? Because these images have the source code of the application, they have the configuration of the application, as well as you can misuse it to create a persistence access of containers. So you can download the registry, you can add your backdoor, and you can upload it again. So there are three types of registry there in containers. We have, first one is Elastic Container Registry. So basically, this is a location where your container registry is located. You can access it using CLI or browsers. This is provided by AWS. Second one, you have a private Docker registry. Just like every organization, or most of the organization have their private registry, especially bank. So they have their own private registry for storing the Docker images. Third one is public registry. Just like you can use Docker Hub to download or upload any other registries. We are really interested about this container registry, or ECR basically. Why? Because you want to check if you compromised an environment or a container environment. Do you have access to container registry? Because if you have access, you can download the registry, you can leak the source code. Second thing, you can also update, you can also add the backdoor for creating a persistence access for a long term. So how its ECR is look like and how we can do that, we'll discuss. Let's click here, Elastic Container Registry. So this is the registry. So you can create a multiple repository. In each of repository, you can store the images. So suppose this, like I have this repository. You can also define if it's a publicly accessible or if it's a private. So publicly accessible, it will be doesn't require any authentication. You can access anywhere using the URL itself. Now private repository, to access the private repository, you need to be authenticated to container registry. So suppose you can create a new registry. It's a public or private. You have to specify the registry name. It's basically a folder, seems like. And inside the repository, you can store the multiple images. So these are the images tag. That means name of these images. You can copy the URL. Same like if you want to access it. So this is how it's look like. This is the your account number, AWS account number, DKR, then ECR and all, Docker images, Elastic Container Services, USEs. Here is you have to define the region. Then this will be your repository name, and this is your image tag as well as image name. You can see when you're going to access this one, it will ask him for the authenticate. So you can access this thing from your command line utility or CLI basically. Let's specify HTTPS. Yeah, it's asking for the authentications. So this is how it look like. Suppose you click this one, the image URI, the digest, SHA-256, when we uploaded size and all these things you can see here. You can also scan this registry. This is really important because you have to create your backdoor in such a way that it won't detected by this scan engine. So if you are able to do that, you can have the persistent access there. You can also create the permissions, who have a rights. You can also put the policy here, and this is really important because here you have to define the policy, which is called resource based policy. You can attach on each and every image. You can edit. You can also edit the life cycle, how we can define the rule for this particular registry. So this is how container registry look like you can store the image, you can create a repository, you can authenticate. We'll discuss about how we can authenticate, how we can edit the backdoor in our persistent sections. So this is all about this video. I think we cover most of the thing related to container services, and basically it's divided into three sections. One is registry, second one is orchestration, and third one is compute overall. So this is all about this video. Thank you so much for watching this video.